Everyone, let's do this. November 14th. What do we have? Maximum element after decreasing and rearranging. You are given an array. Some operation is satisfy these conditions. The value of the first element must be 1. The absolute difference between any two adjacent elements must be less than or equal to 1. In other words, for each I where this, the absolute value, so either decreasing or increasing, right? There are two types of operations you can perform any number of times. Decrease the value of any element to a smaller positive integer. Rearrange the elements to any order, which is the maximum possible value of an element in array after performing the operation. The maximum, so the maximum possible value. Okay, so of course you can always decrease and you can always rearrange. So you're always decreasing it, and okay, you're always decreasing it, you rearrange it. So if you have 1, right, you always rearrange, put a 1 in front. It doesn't matter, right? It doesn't really matter. What we want to do is you sort it, right? Sort the array, and yeah, it has to be like 1, 2, 3. Oh, you cannot increase. You cannot increase. You can only decrease. Which means, so you sort it first, right? Sort it first. 1, 1, 2, 2, 2, right? You sort it and just keep going. If it's a value, you cannot. So if it's a bigger value, then you need to bring it down, right? If it's a bigger value, bring it down. If it's a, oh, what if it's a smaller value? It doesn't matter. If it's a smaller value, we'll rearrange it. Will it always be the best to sort it from low to high? What do you think? What would happen if you don't sort it low to high? Well, I mean, the first one has to be 1, right? The first one has to be 1. And the second one, right? So the first one has to be 1. So the second one is either 2, 1, or 0, right? And you can decrease to anything. But why would you want to decrease, right? If you decrease, that means the potential for the future is always going to be lower. So the maximum is like 1, 2, 3, 4, 5. Right? That's the maximum you can do. Which means if you sorted it, if after you sort at this position, and nobody is 0. So yeah, you sorted it. Right? To a smaller positive integer. Yeah, you sort. If you have a giant value, then you have to drop it down to 2. And if you don't, if you have a smaller value, you just leave it as is. Yeah. If you have a smaller value, you leave as is. If you have a bigger value, you drop it down. And at each position, you try to get the biggest possible, right? Because you want to find the largest possible value. So at each position, you should try to find the biggest possible. All right, so the first position is this, right? The second position, yeah, we can find a larger one, but we'll also have something smaller. And those something smaller is restricted in their position. And if you say I do 1, 2, and you do 1, right? If you have like this, you can now do 3. But if I rearrange it, then you can do 3. So yeah, I think I'm gonna try. I feel like sorting is enough. I mean, honestly, I don't know. So I have to see if there's any anything that I don't realize. Wait, hold on. Arrays dot sort. Why is this not right? Oh, it's not G, it's A. Dude, this is an A. Right? And then so for each one we need to so array 0 need to be equal to 1. Right? It's required. The first element must be 1, right? And then we should say for int I equal to 0, I smaller, no. Right, now length plus plus if array I is smaller or equal to array I minus 1 plus 1, continue. If it's larger than, then we have to reduce it. We say array I equal to array I minus 1 plus 1. And then we'll return array dot length minus 1. I don't know. This feels, I'm not sure. Yeah, we can pass these, but I'll just try. If it doesn't work, well, I guess it works. This is much easier than the CTF I'm trying to do today. Lord, those are, I really have no idea how to even approach those problems. And for each position, find its max possible value based on its previous neighbor. No, it's not what you want to put it. I want to put it here. 15. What's the solution? Greedy. Yeah. Yeah, always greedy, right? That's just. Yeah, you don't even need to. That is true. You don't even need to do this. Yeah, it's okay. No sort. Oh, counting sort. Yesterday's the counting sort. 10 to the 9th. How are you counting sort 10 to the 9th? Let's see. Counts. New int n plus 1. Oh, that is true. It depends on n. Right? It depends on n. So we get that, and then we'll count. Max.min, num and n. Yes, you have a maximum. You have the. If it's smaller, then you put it in. That's true, right? If it's smaller, you can put it in, because the max it can do is n. It cannot get bigger than n. So if you're already smaller than n or smaller equal to n, you have your position. If you're larger than n, then you will go to the end, right? So once you've done that, then you will go through the start, and then we go to 2, and we try to find if it has answer plus counts num and num. Wait, what's that? So counting sort, you have a bunch of those, right? And then you go through the whole thing. Go through the whole thing. Yeah. However many you have at a certain position, then you just add those. You just add those. And answer plus counts. So if I have, I don't know, 0 at that point. Wait, hold on. This I don't understand. We have counts, right? We have counts. And then what we're saying is, if we have answer, because if we have a position we don't have a count, then we just need to skip it, right? If we have count, then whatever answer I have, we can use all the counts. So it'll be plus the counts, right? It'll be plus the counts. And if it's, yeah, shouldn't you be doing the other way, right? Every time you have count, you plus whatever that counts, because they can always be turned into, oh yeah, it has to be, cannot get bigger than num. That is true. You cannot get bigger than num. Yeah, you cannot get bigger than num. As I'm coming to the current position, right? The current position, num is the largest value. And if I have some value at this position, I have some value at this position. And it cannot go beyond this, because you cannot increase, right? The maximum you can reach is num, so we'll pick the minimum between the two. Ooh, this is great. We increment answer by filling as many spots as we can using reduced num. However, the total number of field spots cannot exceed num because you cannot increase. That is a brilliant solution. Great. Yep, I think it's pretty cool. Just counting sort again. Right, the max value possible after array is rearranged is n. Thus, we can count the number of appearances of num in array with the max topped at n. Then we go through the counts, right, and fill counts. If for the current value num counts num is larger than 0, right, we can fill up the rearranged array up to num or afforded or however much affordable by counts num. I hope I understand what I'm trying to say. So there's no sort. Yeah, int counts. Right, length plus 1. For int n of array, actually I like to call a of array, counts math dot a array dot length plus plus, right, and int rest is 1 for int a equal to 2, a smaller equal to, right, dot length a plus plus. We can say rest equal to math dot minimum. Yeah, actually I'd like to do it here. Math dot minimum rest plus counts a or a, right? So for the position and the current value of a, right, the max value in array cannot exceed a itself. That's why I have to find the minimum, right? I have to find the minimum. And at the end I will return rest. This is a great solution. When? Great. All right, so we're done with this. Good. Nah. No intention to do any of these. Graphically smallest string after substring operation. You're given S. In one operation, you can do the following. Select any non-empty substring, possibly the entire string, then replace each one of its character with the previous character of the English alphabet. So it's like a Caesar, but Caesar going previous. For example, B is converted to A and A is converted to Z. Oh, okay. So wrapped around. Return the lexicographically smallest string you can obtain after performing the above operation exactly once. A substring is blah 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 graphically. Okay, so CBABC. We apply the operation on the substring starting at index 0 and ending at index 1. It can be proven that the result string is the smallest. Okay, I think that's interesting. CBABC. Basically, we go from the first and then see if we go front can make it smaller, right? And this go front can make it smaller, so we do. If this go make it smaller, we do. This we don't, so that's that. And if we do ACBBC, this will not do, but this will do. So ABAAB. That's yeah. Everybody can go front. So basically, can we just say that we can, as long as it's not an A, we just always go, and then we stop at A. All right, let's use string builder. Okay, so we can say string builder SB equal to new string builder. Then we say for int I equal to 0, I smaller than s dot length plus if s dot char at I is equal to A. Okay, then we break. Otherwise SB. Ooh, I need to do it this way. While I smaller than s dot length and dot char at I is not equal to A. Y is not equal to A, then we say string builder dot append s dot char at I minus 1. Okay, so we can return sb dot toString plus s dot substring I. We need a plus plus here. All right, I actually don't know how to. That doesn't feel right. String builder. I don't think this is what you. Yeah, it is. Hold a second. How'd you get the string builder, new string builder, append? It is .toString. I don't know why. What did it say? Remove redundant toString call. You don't need a toString call. I don't know. Maybe because we have the add, it automatically turns it into a string. Who knows? Don't judge. Give it a shot. That is very interesting. Well, I guess it's because I didn't do that. Thought it would be enough. No, it's not. It will do the string. Okie dokie, what happened? B A A B C A. Oh, that's true. Ugh, my bad. So we should say while I smaller than start length and s dot char at I is equal to a I plus plus, then do this. Yeah, we need to add this. One more. That should be enough. Yeah, very. Maybe. Can I do s dot substring 0 to I? Is that a correct syntax? Oh, it is. That was pure guessing, you know. That was pure guessing. Oh gosh. All right. So, oof. Damn. You have to do it exactly once. Oh my. So, I don't know. Hold on. So basically here we'll say if SB dot is empty. Oh, if SB is empty. No, SB is not empty. That's not what this is. Dude. Yeah, this is bonkers. Yeah, it didn't read it well. What is the Boolean value? Action performed has performed action performed false, but once we do this we can say action performed equal to true, right? Then we will say, oh Lord, if action not performed, which it means everybody is yes, I know. Basically we say action performed. If action performed, return this. If action's not performed, s dot substring 0 to s dot length minus 1 plus z. Yeah, unfortunate, very unfortunate. But if I have something that's, no, I should do one more. It's just, you know, have one. But I think this one's right. Yeah, the tricky part. Requirement of the problem. Performing the above operation. Skip all the prefix a. Roll back all the any non-A letter following the prefix and break once another A is encountered. Special treatment when the entire string consists of only A. Yeah, it's more on the tricky side, but it's all right. I have no complaint. My God. Ugh. In fact, I do think char might be a better solution for this, but maybe stream builder is faster, slower. Anyway, all right, that's it. I don't want to do another one. We'll call it a day for today. Oh my goodness, people hate this problem. Absolutely hate this problem. All right, I'll see you guys tomorrow.